Today we are going to take another example of knapsack problem. Suppose 5 objects are there and capacity is 12 and profit is according to object 52245 and weight is 54621. So maximum capacity is 12. So we need to get a maximum profit according to minimum weight. Like this we need to see. So here we see like this. So first of all we'll see, suppose weight is 5 and profit is also 5. So if we take, then what we will get. So first we write like this: 1 2 3 4 5, total 5 objects are there. Suppose if we take one full, so what will be the weight? Weight will be 5, and what will be the profit? Profit will be 5. Next, if we take the second one, so the weight will be 4 and profit will be 2. So and next we will see the third one. The weight is 6, so we are not going to take it, so we are putting 0 because the maximum capacity is 12. Now we'll see the fourth one. So if we take the fourth one, so profit will be 4 and weight will be 2. This is profit, this is weight. And the fifth one, so how much? 9 10 11. So we can take last one also. So if we take one, so profit will be 5. So total capacity is become 12 now. So 5 plus 4 plus 2 plus 1, that is 12 now. So we cannot take more than that. That's why we left this in between and we are taking this full one. So how much profit we will get? 16. So profit is 16 and weight is 12 now. So this is one combination. So in that way we can make many combination like this. So we can say simply knapsack feasible solution may be infinite. So we can make many combination. But if we talk about the fraction knapsack, then we can say fraction greedy comes in, fraction knapsack comes in greedy 01 knapsack, and it is in dynamic programming. So as we have seen in the last lecture one example, and in this lecture we've seen one example. So we can say simply, we can write the algorithm of knapsack. So how we will write? First, what we will take for I is equal to 1 to n. How many number of objects are given, according to that we will run it. Then what we will do, we'll assign profit upon weight. We will cross check profit upon weight. We will cross check, as we are cross checking here. So then what we will do, we will sort array A in decreasing order of profit upon weight ratio. Why? Because we need more weight and more profit and less weight. That's why in decreasing order we need to set it. And the third one, what we need to do, take 1 by 1 object into knapsack until capacity of the knapsack becomes 0. So as we have cross checking here, until unless capacity becomes 0, it means the maximum capacity is 12 here. So once we reach at 12, then we cannot take more objects. So this is the way we are doing knapsack problem, and so that's why this is the algorithm of the knapsack problem. So we can take many feasible solution, but I have shown only one, but many feasible solution can be possible, but we need to choose one optimal solution.